Good afternoon, everyone. Welcome to our webinar focused on the ways how to reduce scrap and improve quality. I'm Petr, General Manager of SprayVision, and a lot of you knows also my colleague Wojciech, which is Technical Manager here.
Good afternoon.
Our special guest for today is Sowthriraj Dhandapani from company OP Mobility, which will share their experience with our products and what they did with the SprayCapture. In the first part of the webinar, I will briefly introduce your company and some theory related to scrap reduction and optimization of the quality. Then my colleague Wojciech will share with you very interesting use cases, actually, which we collected from the market, and we believe that are important to share. In the let's say fourth part of our webinar, Sowthri from OP Mobility will share their point of view and their, let's say, integration path with our technologies. Before we get started, I have a few items to cover. This webinar is being recorded, and we will share with you the recording afterwards. Please use the Q&A feature to submit your questions even during the webinar, and we will address them on the end of the webinar. And if you, for example, face any technical issues, please let us know, and our supporting team will try to help you. So that was all, and we can start. As I mentioned, SprayVision actually is the company focusing on the coating process digitalization, evaluation, and optimization of the coating processes. And we are doing it by two products, where first of all, and the main point of today's webinar is the SprayCapture, where actually we are using it for real measurements and real evaluation of the coating process. SprayCapture, as the hardware, is based on the transmission of the light through the coated sample. That's why we need to spray also on the transparent surface and then place it to the capturing unit and based on the data output are able to help with the process control, which is leading to lower scrap, surface thickness measurement, which is giving you full picture what is happening on the substrate and what is the thickness distribution in all points, and many other use cases which we will go through during the webinar. Or partly touch them, let's say. SprayBrush, it's our newest product, and it's pure software, which is having inside digital twin of atomizer, or let's say behavior model, where we are able to recommend, based on the data, most optimum setup with the best transfer efficiency, which will require your request for the specific thickness, specific size of the brush, and the rest actually is delivering the software. So software gives you the information, what pressure you should use, what paint flows, rotation speed for, and so on. And above that, we are able also to provide very good simulation, which is fantastically matching with reality, where you can really, without using and consuming time of the coating line, have the full picture and full understanding what is happening during the coating process on the part and how well looks like the result when it will leave the drying zone. So those were our products and technology. Just a little place it to kind of digitalization path. So a lot of you knows offline robot programming. Then to, let's say, understand more what is happening really in the process, we have introduced the SprayCapture, which is giving objective point of view on the coating process. Another logical step was the behavior of atomizer, which is able to help significantly with finding of the parameters which are efficient and fulfilling the request for the coating. And above that, also providing the simulation on the substrate as the bumper, car body, or even interior parts or any other use case. Kind of ultimate target then might be self-generated trajectory, which is also improving tech time and recommending the parameters for the coating together. Now we will actually cover one of the main topics, which is scrap reduction, and how we are addressing it. It's through our module, which we call process control. Process control is actually based on the static or dynamic spray patterns from the coating line, if you have one robot, you can just spray it, collect it. If you have multiple robots in the spray cabin, you are able to work with kind of skits or any possible way how you are used to collect multiple outputs from the robots, then place it to our capturing unit, which in the top part has the lighting module. Here you place the sample, uh, close it, and in the bottom part is camera system, which is evaluating the captured sample. Once it's done, and it takes around 20 seconds to make this operation, you are receiving the information if output is proper, as you can see on the left picture, uh, or there are some improper distribution, or there is some improper distribution of the paint, as you can see on the right picture. Once there is the improper distribution, it will of course create also issues on the substrate and will create you defect as the striping or proper distribution of the thicknesses. So this is the let's say explanation, the way and workflow, how it's done, the process control. Here, if we step into the higher level of the detail, you can see the two screens on the top. On the left, there is the rotary bell where you can have production standard, and also the captured pattern from the production, which is evaluated from the point of the volume of the paint applied. It's evaluated from the point of the shape and sizes of the inner and outer cycle. Also, it can detect improper distribution of the paints and gives you the possible issues which we can address and how to solve it. Very similarly, it's done for the spray guns, where due to the also knowledge base, we are able to address very specifically if there is some issue, as in this case, there is the heavy center. We can say what are the possible causes of this problem and how to fix it. Mostly are three possible causes and three possible fixing for most of the defects. Yeah, by experience, then you are able to address it more precisely. And again, you are having metrics as the volume matching, as the size, shape, and for the spray guns, even the angle. In the bottom, you see what is happening once there is the issue with the air cap, and there are some improper, let's say, distribution of the paint. So it's understandable from the cone, but then you see it even more in the projected pattern. And with our software, you are able immediately understand how big the defect is and how to make it again good for the coating of the good batches by solving it. Once you are using the cabins where there are more robots, you are able to create very easily the model of the cabin with the different applicators. Once you collect it on the skid, you just take the samples, place it to the unit, and click on the specific robot, and the software gives you green or red light if there is OK pattern, and you can continue production. Or there is some issue, you just need to click on the high level of the detail, understand what the source of the defect is, fix it, and then you can continue mass production again. Once per week, or when you need higher frequency, you are receiving the report where they are actually mentioned the main causes of the problems, how many spray pattern was done, what were main issues with them, and so on. Plus, you are having also kind of the predictive maintenance, or let's say long trend graphs for all the important metrics. So for example, when there is significantly changing the shape in the time, you are able to set up a bottom limit. And once it's on your limit, you can address the change of the air cap once it's overused or used already. So this is the, let's say, process control part, which is leading to significant reduction of the scrap rate. And as I mentioned, Vojta will later show you some use cases. Another topic which is more connected with the quality of the coating is the surface thickness distribution. Currently, you are able to measure in the certain points by microscope ferromagnet, but anyway, you are receiving just informations about spot measurement. With the spray capture, you are able to have the surface thickness measurement, which is giving completely better understanding what is happening on the substrate, how the trajectories and patterns are connected together, if there are some areas where is missing paint, or on the other hand, where there is the accumulation of the paint. And all one or other, you are able to have, or you have also the tool which can help you to fix it and make it more uniform and improve the quality of the produced parts. One example of representation, for example, on the car body, you can apply the foils to areas of the interest, make the coating, and even right in the flash-off zone, take the foils out, or you can also get the foils dry. However, to take it in the wet stage has the significant advantages of the prompt feedback on the surface thickness distribution. On the bottom picture, you can see that on the doors, for example, the paint is distributed quite uniformly. Here on the heat map, you see that there is probably from 10 to 15 microns. In the software, you are able to address even each specific point to understand what the thickness is and to have, again, full understanding how it looks like. However, on the top picture, you can see stripes on the doors, and the stripes could be there from two reasons. First, that there is some issue with the output from atomizer. In this case, for rotary bell, might be typically not clean well, or some problem on the air distribution ring, which is creating the stripes. Anyway, by process control, you can find it out and make intervention to fix it. Or the issue might be with the improper connection of trajectory and spray pattern. And this is something what you can also easily fix and find. Another, let's say, part where a lot of our key accounts it's working are the bumpers. Here I little borrowed even use case from my colleague, where actually you can see that the top picture is representing the stage of the coating when before we have implemented the SprayCapture, and you see that there is the quite deviation of the thicknesses, minimum and maximum. It's quite distanced and improper distribution. Which is also recognizable from the pattern and its dynamic peaks, which you can see here. There were done some couple of tests, and actually the one of them was to decrease partially the rotation speed of rotary bell on 45,000 rounds per minute. And you can see that pattern is much more flatter. The surface or spray pattern, it's more uniform without this, let's say, spot distributions of the paint, and the thickness was more or less maintained. Yeah, so with just this small change, actually, they gained also some little more transfer efficiency. But what is the most important, they gained much more uniform distribution of the thicknesses. And this is just specific use case, but also to show you here how we are able to even measure very complex shape parts, where we can apply just 40mm width tape even on the bumper, and have the full understanding how the paint is distributed. You can also measure, for example, on the lights. You are able to measure on the interior parts. You are able also, we have some special spots, measure on the buttons, for example, buttons on to the interior of the cars, and so on. Many other use cases. However, you can fully trust that your result in the wet stage will be very close to the measurement by ferromagnet or by measurement of the microscope, as in this case. Here, just really briefly, other modules which we have in the technology and are really interesting for the understanding the left one for the let's say scrap reduction, the right one for the quality. So here you are in the software, we are able to detect microbubbles, impurities, and others, but even fibers, for example, in the paint. And then you are able to also analyze and identify source of the defect, and the software can help you to solve it. What has big impact to the quality is the atomization, and here you are able to also understand how paint is atomized and objectively evaluate it when you are changing parameters, how fine is your atomization for that setup. So that was those were slides actually for the surface thickness distribution and the slides which are, let's say, having impact on the quality of the coating. Now I will pass the word to my colleague Wojciech, which will introduce you very interesting, I believe, use cases.
Thank you, Peter. We have first use case where we try to show you like uniformity of the coating. Like we discussed the stability of the coating process and so on, but uniformity of the layer have really big impact on the stability also, because uniform layer means more robust process. So it will create like some buffer if something will change, like size of the pattern or some defect, it will be more stable, that process. And coating, it's multi-physical process. There is many variables which can affect the size of the pattern and quality of the output. Not just the impurity of the air cap or shaping ring, but even the viscosity of the paint, temperature, so on. And not just the impurity, even the wrong setup can ruin your production, what you can see here in this use case. For example, if you overpressured the atomization air, always you are creating the striping, and it's really hard without our technology to even observe that you are facing this trouble. This slide, it's purely about the stability. Many of you are using in the production more robot positions. Each robot position have the setup, air cap, nozzle, and each air cap or nozzle have some lifetime. And you can see that even if you are using like exactly same type of the air cap, in each position there can be the differences because the lifetime of the air cap, or even because the offset of the proportional valve and so on. With our system, you can stabilize it in the way that you can find what's the difference. The system can lead you how to solve the difference in case of the defect. And in case of the differences, you will understand in which metric the differences is. For example, volume. Volume is pointing to paint feeding system. If you will see that mostly you are facing issue and differences in the volume, for sure you need to focus on the paint feeding system. If it will be shape, it's proportional valve, and so on and so on. So the system will lead you to stabilize the process on the really easy way. This is the example of the output from the rotary bell. You can see that even with exactly new applicator, new spare parts, it's not secure that you will reach the OK output. For this, you need to check it before you run it in the production. So here you can see the example of the defected pattern and OK pattern, and you can see really easy the differences. The stability and maintenance, strongly connected. Good maintenance means better stability. Of course, sometimes happen that the maintenance is not such a good as is in this use case you can see. Like, for example, if you are using for the maintenance, like bad tools or bad workflow, as you can see here, the drill for the cleaning of the application, it's a really bad idea. And basically you are not cleaning, you are destroying that application. Again, with the SprayVision, we are able to detect the defected output, and you can set even like what will be the good period for the maintenance. So you don't need, maybe you can observe that you don't need to do 2-3 times per day, maybe just one day. Atomization. Of course, this is really strongly connected with the final quality of the appearance of the paint. You can see here for example, differences in the batch. Sometimes it's happening. Like you have the same paint material, but it's different based on the period of the time. So we are able to analyze even such a big details as is the drop of the atomization. And from the result, you can clearly understand that something was changed on the material itself. It can be viscosity, solid content, whatever. But you have the tool to analyze it and tool to see if that change was there. Improvement, optimization. You can also compare different setup. You can see on which setup of the atomization pressure the atomization it's good, or in which case you're already losing that quality. Here in this example, we have 3 different setup of the atomization pressure and the outputs from our system, and you can clearly by naked eye see the differences, but also we give the numbers. And from the numbers, you can understand which atomization or which level of atomization you should reach. Of course, it's strongly connected with the transfer efficiency. So if you reach really smooth atomization, it doesn't mean that it's perfect setup to use it in the production. You need to combine it with transfer efficiency. And with this tool, you can easily find it out. Last use case, it's for the comparison of different types of the air cap or applicator. Sometimes we see from the customer that they set up wrongly in initial stage the setup of the applicator, the size of the nozzle, type of the air cap, and so on and so on. With our tool, you can compare the outputs and you can choose what's the best setup to use. That was all from my point. I will lead word to Peter.
Thank you, Wojta. Thank you for sharing those use cases. And I think that now that's the part for which you have mostly weight here, and it's sharing of the experience from our great partner, Sowthri from OP Mobility. Sowthri, if I may ask you, please, to share your point of view on these topics.
Yes, yes. Thank you, Peter. Thank you, Vita, for this opportunity. And hello, all from OP Mobility Central Paint team. So we have a few experience to share, and as you know, we cannot share too much, but I would try to give the maximum macro information of our plans. So if we move to first slide. So this is where we are. At the moment, we have deployed SprayCapture around 25 plants. Basically, our objective is to do process control through SprayCapture, and as well as to do thickness measurements. Mainly, instead of waiting for a laboratory to send the parts, to do the thickness measurement wet on wet. And the third we are also using is to characterize the brushes, as you may seen in the previous slides from Peter, to characterize the dynamic patterns. And last but not the least, also it's helping us to move towards sustainability. And if we move to our workflow, as most of your plants, we were using this kind of visual check, having a paper with some limits and doing the same setup every day to see if we are okay in terms of length, and probably if the paint is having the same height in terms of runs. These kind of checks we do visually. I think it helps us, yes. And this is some methodology we have in our plans since long time. But what's changed now is that we are able to have visual as well as we can have the digitalized form of our process control, and not only digitalized form, also it's helping us to have the data stored in database, and we can compare day to day by robot, by booth. And most importantly, when you have some issues in the paint lines, we are able to go back and check what time how my applicator was in terms of process control. So I would say this digitalized form helps us to open our eyes to do more maintenance, or sometimes we don't need to do more maintenance, and we can keep it simple, because now we can decide everything with fact and figures, I would say. So if we move to next slide, this is our workflow. Probably you may know it. We paint it in the plastic foil in this setup in one of our plant. It could be different, but basically we paint and then we put it in the spray capture. And once we put it, we go to the software. Wait. So it's basically what we are explaining is to keep in the limit, don't to cross the limit. And after we go to our software, we can do this kind of comparison. So you may see I move my mouse up and down. I can see what is the film build, if my pattern is uniform and if my pattern is homogeneous, etc., etc. So it's kind of quite fast to know what kind of brush parameter I am using in my part. Even though if my part is having good color, good film build and good production, so these kind of activities will help us to be homogeneous and be more robust for our customers. If we move to next slide, this is an example. We tried to see if the spray capture really helps us. And here you can see that in the paper there is no deviation, and we tried to change the air cap with some blockages. Still there is no deviation, so it means my production can be good with this air cap. But if we move to the next slide, which we replicated this test in spray capture, we can see the difference in the output. So this kind of uh, exercise we have did to see if we can be confident in the results from spray capture. And at the moment we see it is helping us in our plant to be more I would say more confident in taking the decision if I run the production or I stop, and so on and so on. And the last, if we move to the next slide, I would tell few words that yes, it helps us with process stability and the quality improvements, as you may know, due to the facts we see in the software, we can able to do this. And also it's helping us to improve sometimes the stability, and also some film build optimization and so on. And most importantly, it helps us with the fast feedback. We don't need to send the parts to laboratory, and we don't need to wait 2 hours, 3 hours till the part comes out of the oven, and so on, because once it's crossed the flash off, we are able to take the foil and we can have the feedback. So that's it from my side. If there is any question, I will answer. But thanks once again to Peter and Vaita and to all. Thank you.
We would like to thank you, Sowthri, for sharing this valuable feedback, actually, and your point of view on this on the scrap reduction and quality improvements for OP mobility. It was really great to have you here today. As Sowthri mentioned, we would like to ask you to place your questions to Q&A section, and we will be happy all together to address them. So I will start with the first question. Probably you can answer, Vojto. How accurate is the thickness measurement in the ferromagnetic microscope comparison?
Thank you. Our technology is recalibrated by your equipment, what you are currently using during the production. So it's quite easy, short process to calibrate that paint for our technology. But the main gain is that the accuracy is exactly same as you still currently using in the production. So
Perfect. Thank you. Maybe for you, Sowthri, one question. How long does it take to deploy the process control in the process or plant?
Well, it depends. Basically, depends on the situation of the plant because the initial stage we need to spend a lot of time to calibrate the paint, to do some test, to define our golden standard or reference pattern, I would say. And once we have defined our reference pattern, and it's just following the exercise every day. But sometimes if we have a plant with I don't know, if we get if it's a new plant, a greenfield plant, we have all the time. But sometimes in the production plant it takes time. I don't, or I am not able to tell how long. It really depends on the plant and number of robots and how you want to do. If you want to keep only one color for all the process control, or if you want to keep every colors and so on. But basically what I could tell is it's a question of arriving to reference pattern. If you can arrive to a reference pattern in one day, it's done. Or if you need 1 week and so on. So probably I would say 1 month per station. If we are so efficient.
Fully start. Understand.
Yeah.
Perfect. Maybe another question for you, because probably it's addressed to you. What was the biggest challenge during deployment?
Challenge. We did had or we had some initial plant because it was from Open Mobility. We are working with SprayVision since 2020, and initial stage, even me, I don't believe too much the system because yes, no, why I want to try again and so on. This was the challenge. But and once we start to learn, when we noticed it's working, then it's not anymore a challenge because we see it. So the first plant or first few plants will be tough to shift the people, not only technical, but it's a digitalization world. So we need to also change, transform our mindset to more fact and figure and data and so on. But after it's smooth. I don't know if I explained well, but the answer is in the first few plants or until you get confidence, it's a challenge. You need to try to see if it's working, compare. For example, let's imagine film build. You make a film build test, you send the part to laboratory, you check if it's good and so on and so on, and you repeat in all the colors and so on and so on.
Understood. Thank you. Now maybe for Vojta, like a question related to about the starting of the calibrations for SprayVision equipment. We paint water-based base coat. We find that we need approximately 1 week for the base coat to dry completely to do the measurement. How should we process to speed it up? For example, small oven.
Yeah, always it's good to use, like if you have the option of the laboratory oven, it's good to use it. You can place for the longer time the foil there. But we have also some methodology how to solve this still sticky paint. And tips. For example, one of the tips is to flip the calibration foil that you don't destroy the layer and so on. So we have also this covered, and it's possible to do it even with a little bit wet stage still. Yeah.
Yeah, but this was the question from one of our customers actually. So then we can address even specifically this, and we can connect with you to give some more tips to help you with speeding up of this calibration process.
Sure.
Okay, and seems that actually we went through the most of the questions. So I would like to once again thanks to Sowthriraj from OP Mobility that he was our special guest for today's webinar, and would like to thank you all for joining and asking your questions. And looking forward to see you all on some other sessions. Thank you.
Thank you, everybody.
Thank you all. Bye.
Thank you. Bye bye.